This isn't what we were doing. What's going on? Are we here? Okay. Do a little tidying up here. I hope you know the weapon I'm about to use in this particular question. And I'm just going to keep writing steps that I think you're not going to be too stressed out about. And I do want to talk about the next step, and I also want to talk about the weapon that I hope you already have ready. You've already taken it out of your pencil case. You know what you're going to use here. Plus 1,000, minus 1,000. Beautiful. Gone, as we expect. And what's the weapon we're going to use for square rooties? Will? The conjugate. Yeah, it's definitely the conjugate I'm going to use. I'm not going to use it yet, though. I'm going to do something else really clever. A really smart move. I'm warming up for the next really tough example. It's being very, very smart, what I'm going to do here to make my life a little easier. And I'll show it to you in just a second. I also want to mention, because I said I was going to try and give away something about these questions, I want you to notice that conjugate questions get covered in limits. I already sort of promised that there'd be the four kind of different limits, and one of them was you have to use the conjugate to rationalize in limits. I see some noddings like, yes, I've done a bunch of those. So to do it here again, sort of repetitive. I don't know if that's the choice I would make if I was writing the test, which I am. These are good practice for your conjugates, but just an extra little hint going into your week of rest. Here's my great move. I like it so much I'm not even going to explain it before I do it. Gives it some drama. I'll move my little recorder button down here for a little while. What did I do? Josiah, what did I do? A common factor, that 10 out front. And it really simplifies the algebra. You don't have to. But, wow. The conjugate just got easier. The conjugate I was going to use a minute ago was 10 root a plus h plus 10 root a. And you just know multiplying 10's back. There's just a lot going on there. Now my conjugate's nice and simple, so I'm going to write it in red. Here's the nice simple conjugate. Well, nice and simple. Here's me calling root a plus h plus root a simple. No, that's not simple at all. But it's sure better than having those 10's hanging around. And let me just say this part again, because I really want to get through to you about conjugates. Conjugates are there to multiply with their conjugates. Don't multiply them out with the other parts. So in the numerator, I get a plus h minus a. I hope you're getting really good at those. Conjugates is another thing that the first couple times you do it, you think it's really, really difficult. And then if you get used to what's happening with the conjugate, you go, this is beautiful. I love using the conjugate. Bang, bang, bang. The numerator becomes a lot simpler. And that's the point of the conjugate. The conjugate's the perfect thing to simplify that numerator. Well, I'm going to zip through the rest of it. Not that I won't take questions, but I hope the rest of it is not the worst. If you've been madly keeping up with my copying, I dropped a square root somewhere along the way there. So I've just fixed that. Okay, I zipped through a bunch of steps. I'm sure that you got some clarification that you want on some of those steps, but I'll wait and find out what that clarification is. Yeah. I subbed in h equals 0, so the bottom was a root a, and root a, 2 root a. No, not L, a. Yeah. Now I brought the 10 back because the limit was gone now. It was a common factoring thing, and why I can do that is that limits are very friendly. You want to multiply by 10 now? You want to multiply by 10 later? Yeah, whatever you want. It's good. Other questions about these steps? I'm not trying to imply they're easy. I'm just trying to imply that I think those steps, different people might have different problems with them. So I got them all up there so you had time to try and digest them all at once. Questions about that? Who needs more time? More time? What time's your break? 10:35? Okay. Good? More time? Good. Control it. Last one. A spherical balloon is inflated by an electrical pump. Determine the rate of change of volume when the radius is exactly 6 centimeters. All I'm going to put on this page is the volume formula. And I hope I've taught enough that when I write down the volume formula, you see two major difficulties coming up with the algebra. Does anyone know the equation for volume of a sphere? Oh, why did I do that little doodah there? Volume equals 4/3 pi r cubed. A couple things about this formula. It's very mysterious. But by the end of this year, I'll do two things. I'll establish more about why this is the formula for spheres. And I'll give you the beginnings of the weapon it takes to actually come up with this formula. Because in grade 9, it was just like, this is volume of spheres. That's the end of it. I had a cute little PowerPoint that sort of went, well, maybe it's because of this. You know what I mean? And then sort of explained it. But there's been no real explanation of this so far. Pretty simple formula for a pretty simple, pretty complicated formula for a pretty simple shape, and yet we can't explain it with any math we've got so far. But we're close now. Yeah? What's the major difficulty that you see looming here, though? What's that? Okay, well, let's just start, and then we'll establish. Hopefully you'll see in the middle of this that this thing's got some problems going on with it. And because it's got some problems, folks, what I'm going to do, because they gave me the A, is I'm going to go back to the old way. It's not really the old way yet, but it's because we just did it yesterday. But I'm going to go back and go ahead and use that 6 at the start just to simplify my life a little bit for a cubic one. Okay? M tangent equals limit as h approaches 0, volume at, it was a 6, right? 6 plus h minus volume at 6 over h. Limit h approaches 0. Volume was 4/3 pi times 6 plus h cubed minus 4/3 pi times 6 cubed. Do 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 do. Do 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 do. Do 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 do. I gotta tell you, no calculus question's ever gonna let you do this in decimals. Nor do you want to. You don't want to be carrying around some nasty decimal through all this. I'm going to show you in here, hopefully, why you don't want decimals. As long as you can do your algebra right, you can avoid all the 2.745, all that stuff that popped up on your last test, right? All those 5 decimal places, how many of these do I got to write down? We can avoid some of that sometimes if we're just pretty good at algebra. 2 big problems. What are the 2 big problems that make this question scarier than the previous ones? Will? Yeah. That's why I did it with the 10. It was sort of overkill to do with 10. You would have handled 10 no problem. But I showed it so you can see, oh, I can just bring that 10 out front. Well, isn't that, look at 4/3 pi, 4/3 pi. And in these type of questions, they almost always have the same common factor of it. So let's just make our life easier right now. And before I even get going, take that 4/3 pi out front of the whole mess, and then look at what happens. Isn't that nicer? I mean, just really look at what that accomplished. This line is like, that makes you want to cry. And this line's like, oh yeah, okay, 6 plus h cubed, no biggie. Now that we're down to here then, what's the other difficulty of this particular question? It's got a cube in it, and that's a little bit more than you want. Now, but here's the thing I want to show you. Let's just imagine for a second that you do enough homework on your week off. I'm addicted to that joke, eh? That 6 plus h squared becomes easy. Where when you look at 6 plus h squared, you don't even have to write 6 plus h, and expand it out anymore. You're just in your brain going, okay, well, it'll be 6 times 6 is 36. Then 6h is, but there's 2 of those, is 12h, and then h squared. Let's just imagine that that happens for you, that you get to the point where it's like, boom, boom, with 6 plus h squared. Suddenly 6 plus h cubed isn't quite so intimidating anymore, because 6 plus h squared is pretty straightforward. So if you want 6 plus h cubed, I'm not saying it's easy, but you're just taking 6 plus h and multiplying it by the thing that you thought was sort of easy. That is not how I did the expansion yesterday. I went all the way through it and showed all the individual steps. I'm trying to fast forward here a little bit to go, if you do a bunch of the squared ones, cubed ones become a little less intimidating. So then I'm going to multiply out these brackets. So I get 216 plus 72h plus 36h plus 12h squared. 216 is 72h. Oh, I skipped one. Not that you can do it in whatever order you want, but 216, 72h, and 6h squared, then 36h, and 12h squared, and h cubed. Let me look. 216, 72h, 6h squared, 36h, 12h squared, h cubed. And then before I even put it in there, I'm going to simplify things up. It's h cubed and 18h squared, 108h, and 216. Let me just check if I did that right. H cubed, 18h squared, 108h, and 216. Where are the data management people? Anybody take data management already? The odd person takes it in grade 11. 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3, a cubed, a squared b, ab squared. Yeah? Pretty good stuff. You don't need it here. So if you're like, wait, was I supposed to take data management first? No, but there is some applications to some of the stuff you didn't have data management here. How many have data management this year coming up? Okay, good. Exciting stuff. It's a great course. It's different than these courses. Advanced functions in this course start off hard and just get progressively harder, where data management sort of goes all over the place. There's chapters that are really easy and chapters that are really, really hard, so don't underestimate that course. Okay, back to here. Oh, any questions about the expansion? I've done it sort of fast on purpose. I want you to get the idea that actually it's not as bad. When I first do them, you're like, oh, expanding cubes. You do a couple of them, practice it out. It's not the worst. I don't know if I want you killing time on a test doing cubics at this point, but they're there. They're good practice in the homework. 4/3 pi, limit as h approaches 0. And my expansion was h cubed plus 18h squared plus 108h plus 216. That's the expansion that I just replaced there. Minus 6 cubed. What's 6 cubed? 216. Had to be. Had to be. Equals 4/3 pi. Those go. 216 and 216 goes. I'll get that common factoring done. H bracket h squared plus 18h plus 108. Cancel those h's. Limit h approaches 0 equals 4/3 pi limit h approaches 0 h squared plus 18h plus 108, and I get 4/3 pi times 108, 432 over 3 pi equals, does it divide? I think it does. 144 pi, which you can get as a decimal. I hope you have enough experience in pi now to go, pi's not some magical thing. It's 3 and a bit. Yeah, if you want to multiply it out and get the decimal, you go ahead. Did we use IROC last year? No? Yes? Maybe? Instead of writing instantaneous rate of change, good math shortcut, IROC. Okay? 144 pi. Check out the units on this, though. The units are very, very weird. The units of change of a sphere that you're inflating would be centimeters. Is it centimeters? Centimeters cubed per centimeter. Is that the weirdest thing you ever saw? But think about it for a second. It's growing like this, and so we're saying how fast is it going? How many centimeters cubed are you adding for every centimeter radius that you're growing? So the centimeters per cube per centimeter is right. And technically, centimeters squared is also correct. How much does the volume change by? By the surface area. You know, that's what you're adding on to it every time. So centimeters squared is also correct, even though this is more descriptive. Centimeters cubed per centimeter, as weird as it looks, it's correct in saying what's happening. Question? No, let's just rewind. Let's say right at the start I went, oh, can't we do this in decimals? And I did 4/3 pi, which would have been 12.56 divided by 3, 4.18 or something like that. And through all this thing, 4.18, 4.18, 4, you know, hey, decimals are just messy. You know, that's the biggest difficulty. They're inexact as well. And this is nice too, 144 pi. It's perfect. It's easy to write, and it's not rounded off. The next person can decide what they want to do with this information and round it off. 144 is pi. And so lots of times in the question I'll say, leave your question exact, and I'm saying leave it like that. I don't want decimals here. And I'm actually trying to save you from all the decimal nonsense. Oh, he's got a great question, folks, and I've got a great answer. Listen carefully to his question and my answer. He said, did we find the slope or did we find the instantaneous rate of change? And my answer is yes. It's the same thing. The slope of the tangent is the instantaneous rate of change. They have slightly different interpretations, so that they're not exactly the same, but they're the same value. Slope of a tangent means we're looking at the graph. Instantaneous rate of change is we're really talking about the word problem situation, but they're the same. Yeah? Yeah, because it was going to be cubed and because it was going to be 4/3 pi, I just reeled it back a little bit and said it's a little, for most people, it's a little easier to work with the 6's than the r's. So in this particular question, I went, okay, let's not carry the r all the way through, or an a, if you want, all the way through. But again, you're free to do it either way. mostly. Why aren't you free to do it in a question like this? Because I don't have an A. If you don't have an A, you can't use it. If you do have an A, then it's up to you to decide. You're like, okay, just to make sure I get this right, I'm going to use the 4 in there because I'm better when it's a 4, or I'm better when it's a 6. If you're like, no, I like the A's all the time. But there is a homework question. Here's my final hint. There is a homework question that literally says, if it was doing this, it would have said, find the instantaneous rate of change at A centimeters, forcing you to use the A in that particular question. So when you run into that, know that, hey, I'm stuck. So I don't always get the choice. But when I do have the choice, then of course I can do what I want. There was a hand that went up and went down. It's another situation that I stare at for a long time, and I guess I'm just not old enough and cranky enough yet to really get too upset about units, even though I think your science teachers would hate me for it. You know, be like, why don't you kill them about the units? I'm like, look at this. It's amazing. It really is unbelievable what we can do now. 4 marks, and I'm going to take a half mark off at the end for centimeters cubed per centimeter. So what I'll say about units is, if I get to a question that I'm really on about units, you'll get that bold. You know, teachers put that bold, make sure to include units. I'm not giving you permission to forget units. I'm really not. I'm just saying, in the big picture, it might not be what we're focusing on here just yet. But I like mentioning it because it's good to understand the units are important of what's going on here. Yeah, it has to be both of them in the numerator to do it, but it will be, because I use the same formula for both these. It's literally v at this and v at this, so any coefficient that's in there is going to be there every single time. So if it's like a surface area 1 and there's a 4 pi in there, you can just pull the 4 pi out. And maybe it's not about being easier, maybe it's about being lazy. Can you imagine if I had to write 4/3 pi in front of every one of these terms all the way through? It's just asking for trouble, where putting those common factors out there is so nice. So rewinding now back to 10 academic and so on, where all of a sudden we throw a common factor question. You're like, oh, why did you put a common factor one in there? Like, it was all warm up for this to go, let's make sure we're great at common factoring when the time comes up. Yeah? Yeah. Think about a balloon. And let's say the balloon was 5 centimeters in radius, 5 centimeters big. And then I start blowing it up. I hook my inflator up and it grows. What's growing about it is the centimeters cubed. It's changing by so many centimeters cubed, but for every centimeter. Now, if you've ever blown up a lot of balloons or inflated spherical things for your kids, you know something about balloons. And here's the little fact you need to know about balloons and why it's so important here is, when you first start blowing up a balloon, the first few breaths are like, yeah, here we go. But to get a balloon from this size to even a little bit bigger takes a lot of breaths. Because it's growing in all 3 directions, it stops growing as fast. And so that's why it's interesting here how fast it's growing per centimeter as it inflates, because it's going to slow down. At first it's going to be like, woo, and then it's going to be like, yeah? And so what we're saying is, how many centimeters cubed is it growing for every centimeter it grows? How much volume is being added for how much the radius changes? So when you go from 5 centimeters radius to 6 centimeters radius, how many little cubic pieces of air have you added on in there? That's why it's centimeters cubed per centimeter. It's weird, right? It's weird to look at. It's intimidating to look at. You got to spend a lot of time thinking about it. You know, and go, oh, centimeters cubed per centimeter. As you're falling asleep tonight, it's a good thing to think about as you're falling asleep. I don't know about you, my brain works perfect at that time of night. There's like no distractions. I go, okay, let me get to the bottom of this. Centimeters cubed per centimeter, and then you'll be like, oh, I get it. Great questions. Other questions? That's the end of what's on the test for Monday at 1. But there was something else I wanted to tell you. But I'll stop the video because it doesn't relate to